Welcome back. Today, before we continue analyzing definitions of probability, we're going to be doing two very specific concepts that are important in the development of the probability definitions. These concepts are the concept of intersection and union of sets. As you can see, an intersection is all the elements that are common between two given sets. For example, we have set A, formed by this figure in here, this Venn diagram, and we have set B in here. And as you can see, the one in the middle are elements that are shared by both A and B. That is what we call intersection, and we identify the intersection with this symbol. Then we're going to talk about union, all the elements that belong to two given sets, even if they have an intersection. That's why we have a shaded region that involves all the elements of A, all the elements of B, and their intersection. We identify union with this symbol in here. But now that we know graphically, in a very graphical way, the concept of intersection and union, let's do some problems about them. And in the problems, we will be doing a combination of Venn diagrams and notation for sets in combination. So let's see what happens. Example number 1 says find the intersection of the sets given that set A is equal to 8, 9, 10, 11, 12, and also number 7. And set B will be equal to 10, 11, 12, 13, 14, and 15. Okay? So we will proceed to find out what is the intersection of them. So basically, we're going to use the help of a Venn diagram. Okay? So we will draw a Venn diagram containing this information on it. So the Venn diagram will go like this. You make the corresponding circles for set A and set B. And here, we're going to be writing all the elements that belong to set A. And if you already check out, there are some elements that belong to A and belong to B also. So, 7, 8, 9, 10, 11, and 12. These are the elements of set A. Then we draw the elements of set B. And if you see 10, 11, and 12 are already there. So I only need to complete 13, 14, and 15. So as you can see in here, if we want to solve it graphically, what we look for is for this shaded region that I have in here. Okay? And we analyze the elements that we have inside of it. Using the set notation, what we are going to have is A intersection B will be formed by the elements that belong to the intersection of A and B, or in other words, the elements that are common to A and set B. In this case, 10, 11, and 12. Okay? This is how you solve a problem involving intersections, okay, between two sets using what we call the Venn diagram, okay, and using the set notation. Let's remember again, the Venn diagram. And this is what we call set notation. in here we have a situation of intersection and elements belonging to the intersection. Now let's see a second problem about intersection, and let's see what happens with it. Okay? In this second problem, we're going to analyze a very, very specific situation that may occur. Okay? We always need to consider all our possible answers. Okay? Number 2. Example number 2. Find the intersection of the sets given that set F is 1, 3, 5, 7, and 9, and set G is equal to A, B, C, D, and E. Now, what is the characteristic that you see in these two sets that we have in here? Basically, there is absolutely nothing in common between them. So, as you can see in here directly, you can already deduce what type of answers we're going to have in here, but let's make it with the graph of the Venn diagram. So what we have in here is our universe, and set A in here with the elements 1, 3, 5, 7, and 9. Set B, sorry, we were using F and letter G. And in here we have set G that involves A, B, C, D, and E. And as you see, we don't have absolutely anything in common between them. Therefore, that's why the circles are not overlapping one each other. And if we have this situation, then we have no intersection. What this is telling me right now is that I don't have any intersection. So we have no intersection. No intersection. No intersection between the sets. And if we have no intersection, then the answer to this problem will be A intersection B, F intersection G will be what is called the empty set. Empty set means there are no elements in common between them. So this case will be an empty set. Why? Because we don't have absolutely anything in common between them. So this is the symbol that will represent no intersection at all between the elements. Okay, I hope that you understood correctly the concept of intersection, because now we will go with the concept of union. So, now the concept of union is a little bit easier, because in here what we are going to deal is with basically all the elements that belong to the two sets that we have in discussion. So let's analyze this case. Determine the union of the given sets. We have set A being 10, 12, 14, 16, and 18. B being 16, 18, 20, 22, and 24. Now, the intersection Okay, well, let's analyze what happens with the intersection. The universe that we're going to create is going to go like this. So we're going to have, and as you can see, some elements in here also belong to this set. So this has to be reflected when you do the Venn diagram. So we have this in here, we have this in here, set A, set B, and the elements that are in common are 16 and 18. The ones that are just for A are 10, 12, and 14, and the ones that are just for letter B are 20, 22, and 24. But since we're talking about union, and the concept of union says all the elements that belong to A, all the elements that belong to B, and if there is an intersection, also all the elements that are part of the intersection, then the shaded region will be like this. That means all the values that are inside these two sets and their intersection. Therefore, if we write the set notation, we will end up having A union B will be the elements that are only A, 10, 12, 14. The elements that are only B, 20, 22, 24. And the elements that are part of their intersection, 16 and 18. You can write this answer also in the correct order if you want to, okay? There is no problem with that. Basically, because we don't have any relationship between the elements except that they belong to A or B, and in this case that we have an intersection. So here we have the union of A and B, specifically. Now let's analyze a problem that contains also a union, but in this case one that doesn't show an intersection. How are we going to deal with it? Let's analyze. We are talking about example number 4. Let's determine again the union of the given sets. So we're going to have set A being 2, 3, 4, 5, and 6, and set B being 5 halves, 7 halves, 9 halves, 11 halves, and 13 halves. And what are we talking about? We are talking about any possible numbers that you can imagine. They can be part of a set and they can be analyzed as union or intersection. But if you see there is no relationship between the elements of A and the elements of B, that is because they don't have any intersection at all. So if they don't have any intersection at all, then we can write the Venn diagram in the following way. The Venn diagram can be overlapped like this, but in the overlapping area, we are not going to see absolutely anything between them. Right? So we are going to have in A and in here B, all the elements that belong to A, 2, 3, 4, 5, and 6. And B contains the fractions, which is 5 halves, 7 halves, 9 halves, 11 halves, and 13 halves. Once that we have that, we proceed to analyze the union. Remember, there is nothing in common between them. That's why the intersection of the two sets is left empty. So, what we talk about union if we want to do the shaded region, is all the elements that belong to A, all the elements that belong to B, and if they have an intersection, you also include them. In this case, we don't put them. So basically, what we call in here A union B will be the following set. All the values of A and all the values of B. And in this case, I'm going to write them in the correct order. So I'm going to have 2, 5 halves, 3, 7 halves, 4, 9 halves, 5, 11 halves, 6, and 13 halves. And in here you have all the elements that belong to the union of A and B. Hoping that everything was clearly understood. Let's hope to see you the next time. Goodbye.